in this video, we're going to try to derive the quotient rule. And I always find that when I know how to derive a piece of math, I always remember it much better. So in this video, we're going to try to derive the quotient rule. And if you remember what the quotient rule is, it means if you have a function f of x and a function g of x, that the derivative with respect to x of f of x divided by g of x, that this equals the derivative of f of x, f prime of x, times g of x, minus f of x times g prime of x, all divided by g of x squared. And this is pretty unwieldy. It might be quite hard to remember, which is why I think it's a good exercise to go about trying to derive this for ourselves, figure out why it works. And to do this, we're going to need one last function, h of x. And h of x we know is going to equal 1 divided by x. And this h of x function is going to be the key to deriving this, because we're going to turn it from a function division that we might not know how to do into a composition of functions that we can solve. So let's get on with it. F of x divided by g of x. Now that we have this h of x function, we can rewrite this as f of x times h times 1 divided by x times h of g of x. And now if we were trying to find the derivative of this, we're trying to find the derivative of this expression. What is the derivative with respect to x of f of x times h of g of x? Well, now this is something we know how to do. We can say, okay, step 1 can be to use the product rule, because we have the multiplication of two functions, and in taking the derivative of our products here, of our factors, we're going to be also using the chain rule. But we know what the product rule is, we know what the chain rule is, so we can extend it to this division case. So let's get going. The first step, wrong color. The first step will be to take the derivative here of f of x, because we're going to be using the product rule. So this is going to equal f prime of x times h of g of x times h of g of x. And now we're going to add on f of x times now the derivative of h of g of x, which, if we remember using the chain rule, is h prime of g of x, is how fast h is moving at g of x, given a small change in g of x times, well, how much of a change g of x is going to give you. This is the derivative of h of g of x. And now, if we do some simplification, we can remember, well, f prime of x, h of g of x. H is just 1 over x, so this is really f prime of x divided by g of x. And then we can go on and we can add on f of x, and then times g prime of x. And here we can try to remember what is h prime of x. Well, if we go back up here, h prime of x is equivalent to the derivative of 1 over x, which is just negative 1 divided by x squared. So here we can divide by, well, h prime is taking g of x, so we say negative g of x squared. And now you might see there's an easy way to give these two fractions common denominators, is by multiplying this term here by g of x divided by g of x. And this is, of course, 1, so it's okay to do that. But in doing this, we will get f prime of x. Let's scroll to give ourselves a little bit of room. We'll get f prime of x times g of x divided by g of x squared. divided by g of x squared, and I'm doing it in the middle there because it's going to be the denominator for both fractions, minus, we're just going to take this minus sign up to the top, minus f of x times g prime of x. And this right here, this is none other than the quotient rule, and we found it. We found the quotient rule by creating this function here, h of x equals 1 divided by x, and rewriting our quotient rule in terms of h of x so that we could just use the chain rule.